Pluto, once dismissed, now at the center of a cosmic controversy. Once classified as the ninth planet of our solar system, Pluto has long been considered a distant, elusive, and less prominent celestial body. But now, this icy world is back in the spotlight. Thanks to recent provocative statements by renowned astrophysicists like Neil deGrasse Tyson and Michio Kaku. According to them, Pluto could be on a potential collision course with Neptune. How could such an event be possible? And what might be the consequences of a clash of this magnitude? Could we be on the brink of witnessing a rare and unpredictable cosmic event? Or is there a deeper, more complex truth behind this alarming speculation? Join us as we unravel the mysteries surrounding a potential Pluto-Neptune collision. Pluto, reclassified as a dwarf planet in 2006, has continued to captivate astronomers and space enthusiasts alike. The latest speculations from leading experts suggest that Pluto's orbit may bring it perilously close to Neptune's, sparking concerns about a catastrophic encounter between the two. Such a collision, while unlikely, could have far-reaching implications, even for Earth. But how could this even happen? Pluto's journey around the Sun is anything but ordinary. It takes an astounding 248 Earth years to complete a single orbit. Since its discovery in 1930, it hasn't even completed one full revolution. What makes Pluto's orbit particularly unusual is its extreme elliptical shape and steep inclination, tilted at about 17 degrees to the solar system's general plane. This causes Pluto to follow a far more erratic path compared to the near-circular orbits of the major planets. Even more fascinating is the fact that, for about 20 years during each orbit, Pluto actually comes closer to the Sun than Neptune does. This unusual positioning naturally raises a question. Why haven't the two ever collided? The answer lies in the delicate ballet of gravitational forces within our solar system. After Pluto's discovery, astronomers worked diligently to decode its puzzling orbital behavior. Its steep inclination and eccentric path made an outlier, but not a rogue. Despite Pluto's orbit intersecting Neptune's, a collision is prevented by the complex mechanics of celestial dynamics, particularly something known as a three-body problem, which analyzes the gravitational interactions between three massive objects, such as Pluto, Neptune, and the Sun. This system stability is largely maintained by a phenomenon called non-concurrent libration. In simpler terms, whenever Pluto crosses Neptune's orbital path, the two are always at least 90 degrees apart in their orbits, ensuring they're never in the same place at the same time. It's like a cosmic choreography that keeps them perpetually out of sync. Another protective mechanism is orbital precession, the slow, vertical shifting of a planet's orbit over time. When Pluto comes closest to Neptune, it is actually well above Neptune's orbital plane, providing an added buffer against collision. Adding further stability is a lesser-known phenomenon known as Viesque wobbling, named after scientists Zell, Xiao, and Kai, who studied gravitational interactions among distant celestial bodies. The subtle wobble caused by gravitational tugs between Pluto, Neptune, and the Sun helps smooth out Pluto's orbital motion over long periods, even though its path seems erratic. Ultimately, these stabilizing forces demonstrate that even in the chaos of space, hidden patterns and gravitational checks are at work. The interplay of these forces ensures that, despite appearances, Pluto's orbit is remarkably stable. Understanding this dynamic system not only helps us appreciate Pluto's place in the cosmos, but also provides a window into broader mechanics that govern the outer solar system. Simulations conducted in the late 1980s confirmed that Pluto's orbit, though unusual, is far from doomed, thanks to the elegant solutions provided by gravitational physics. The forces influencing Pluto's orbit are remarkably complex and unpredictable. Even minor changes in its initial position or velocity can lead to drastically different outcomes over time. Despite this sensitivity, long-term simulations reveal that Pluto's orbit remains stable over immense periods, spanning millions or even billions of years. To understand Pluto's motion, it's essential to consider the gravitational pull of the giant outer planets, particularly Neptune, Jupiter, and Saturn. Neptune plays a critical role by locking Pluto into a special orbital resonance. Pluto completes 2 orbits around the Sun for every 3 that Neptune completes. This 3:2 resonance acts as a stabilizing force, preventing close encounters between the two. But Neptune isn't acting alone. Jupiter, with its immense gravity, contributes further to stabilizing Pluto's orbit, while Saturn's influence adds another layer to this gravitational balancing act. Together, these planetary giants create a gravitational framework that keeps Pluto on a predictable path and prevents catastrophic events like planetary collisions or orbital ejections that would otherwise destabilize the solar system. The idea of Pluto colliding with Neptune may sound alarming, but it illustrates the subtle intricacies of celestial mechanics. By studying such scenarios, scientists gain deeper insights into orbital stability and the hidden order within apparent chaos. Although Pluto's orbit appears erratic, it is, in fact, an example of a delicately balanced system governed by resonance, vibration, and precession. This orbital chaos highlights a fascinating concept in astrophysics: how a celestial body's future trajectory can be extremely sensitive to its initial conditions. Automated simulations have proven invaluable in this area, modeling how gravitational forces from Neptune and others affect Pluto's movement. These models show that even tiny changes in starting conditions can lead to wildly different outcomes, underscoring the difficulty of making accurate long-term predictions. Despite its unpredictable appearance, Pluto's orbit has shown remarkable stability over geological timescales. This suggests that even in systems prone to chaos, an underlying order still governs their behavior. Accurately predicting Pluto's future path is a monumental challenge. The chaotic nature of its orbit means that even the most advanced numerical models rely heavily on highly precise starting data. A minor miscalculation can throw off projections significantly. Still, Pluto's story reflects more than just celestial uncertainty. It symbolizes a dynamic and ever-evolving nature of the universe. It also reminds us how much we still have to learn. Understanding how massive planets like Jupiter, Saturn, and Neptune influence Pluto's trajectory reveals the interconnectedness of the solar system and how each planetary body plays a role in the overall stability. This raises a key question. If stabilizing forces are keeping Pluto safe, why are astrophysicists suggesting the possibility of a future collision with Neptune? Renowned astrophysicist Neil deGrasse Tyson, who famously advocated for Pluto's reclassification as a dwarf planet, offers a compelling perspective. He and others continue to explore the mysteries of our solar system, including Pluto's future, with open curiosity. Their concerns reflect not certainty, but the acknowledgement of how much remains unknown about the hidden dynamics of space. Reframe passage. The perception of Pluto and its role within the shifting framework of our solar system continues to evolve. Neil deGrasse Tyson views Pluto's reclassification not as a demotion, but as a necessary correction in light of our expanding knowledge of celestial mechanics and space exploration. To Tyson, celestial dynamics are a journey of continual discovery. The intricate and sometimes unpredictable nature of Pluto's orbit highlights just how much remains to be understood about the universe. While Tyson remains hopeful about our growing comprehension of space, his comments on the hypothetical collision between Pluto and Neptune reveal that many cosmic questions are still unresolved. Could Pluto truly collide with Neptune, or is this simply a misunderstanding of orbital behavior in a complex and evolving system? Only time and further study will reveal the truth. In the meantime, such speculation sparks deeper curiosity about the vast unknown still present in our own solar neighborhood. The notion of a possible Pluto-Neptune collision pushes scientists to investigate the forces that govern planetary motion. A collision between these two bodies, Pluto, a small icy dwarf planet, and Neptune, a massive gas giant, would offer profound insights into gravitational dynamics and the long-term evolution of the solar system. Their differences are stark. Pluto's surface is coated in frozen nitrogen, and its atmosphere is composed of nitrogen, methane, and carbon monoxide, while Neptune's atmosphere is made primarily of hydrogen and helium. Such a clash would likely produce observable effects on a cosmic scale. However, the likelihood of an actual collision is extremely low. Neptune's gravitational pull, while strong, is not acting in isolation. Jupiter, the solar system's largest planet, also contributes significantly to Pluto's orbital stability. Saturn adds yet another layer of gravitational influence, further complicating the intricate ballet of celestial bodies in the outer solar system. Despite intersecting orbital paths, Pluto and Neptune are locked in a remarkable 3:2 orbital resonance. For every 3 orbits Neptune completes, Pluto completes 2. This resonance acts as a cosmic safeguard, ensuring their paths never result in a direct collision. It's a striking example of how gravitational mechanics can create stable, harmonious motion even amidst chaos. Nevertheless, this balance isn't guaranteed forever. Minor shifts in planetary velocity or position, triggered by external influences such as a passing star or internal factors like tidal forces, could gradually disrupt this resonance, potentially leading to unexpected outcomes. Ongoing observation and modeling are vital to understanding the long-term future of these interactions. As technology progresses, astronomers will continue to refine orbital simulations and identify subtle influences that could affect the dynamic between Pluto and Neptune. One such possible influence is the hypothetical Planet 9, a still undetected body thought to reside in the distant reaches of the solar system. If real, its gravitational presence might significantly alter the orbits of distant objects like Pluto. The situation becomes even more complex when considering that our solar system itself is in constant flux. The sun, which anchors everything with its gravity, is gradually losing mass through solar wind. This slow loss could cause all planetary orbits to expand over millennia, potentially affecting orbital resonances like the one between Pluto and Neptune. Additionally, the outer solar system is teeming with transient objects, comets, asteroids, and other icy bodies that pass through and subtly tug on the planets with their gravity. Though rare, these interactions add to the unpredictability of long-term orbital behavior. Taken together, these factors ensure that Pluto's orbit remains dynamic, shaped by a symphony of gravitational forces. The cosmic dance between Pluto and Neptune stands as a testament to the universe's intricate design, a balance that holds for now, but may not last forever.